Everybody, this is Itsu. Okay, still working on my nano-pulser in this coaxial tube-like construction. I moved my high voltage probe from across the diode, which I have this 1900 volts pulse, and I moved it all the way over to directly across this nano-pulse tubing, coax tubing. But when I put the same voltage on the drain, it's supposed to have a nice peak signal nano-pulse there, but this is the signal I now measure, and this is by far a nano-pulse. We are at 196, almost 200 volt peak to peak, but it's just a ringing signal, and it's at the repetition rate well, it's not catching it at the moment, but it's at 2.5 kilohertz or something. I'm supposed to have there a very positive pulse, but somehow it's an AC kind of signal, so no nano-pulse at all. So then of course there's no way we have this electrolysis going on, I guess. So I have to find out why, where my pulse is escaping somewhere on this coax line. I don't think it will be absorbed by this coaxial line. Perhaps I should try another coaxial line. This is just 75 ohms coaxial cable, so I'm not sure why I am not seeing my pulse back where it's supposed to be in this coax tubing construction. I will try some other cables and see if I can get it back there. Okay, thank you for watching. Okay, I've removed the coaxial cable from the nano-pulser. I wanted to make sure that there was no short in this coaxial cable, so I was trying to measure some resistance with the tubing in the electrolysis, in the electrolyte, in the cell. But I was getting some strange readings on the ohm level. It was climbing, and so I'm measuring now the voltage, and we can see here we have 633 millivolts between the inner and the outer tubing. And if I shorten them out like now, and when I remove the short, then it climbs up again, so we are building up some voltage from the cell. So it's very hard to measure accurately the resistance. Change to ohms now, it goes up from a few hundred kilo ohms till mega ohm. So I will try just to swap out the coaxial cable with a short piece of wire, and see if I still can get my my nano-pulse back to the tubes. I hooked up a short piece of speaker wire directly to this coaxial tubing. And from my ham radio years, I remembered that the speaker wire also should have an impedance of 75 ohms, so should be similar as the coaxial cable I was using, only this is symmetric. I have the high voltage probe hooked up again across the diode, and I will crank up the voltage now again. And we are at 100 volts DC on the drain, and we have now a peak-to-peak voltage of something like 1500 volts, but when I increase 1400 volts peak-to-peak, we are at 500 volts per division. But when I increase the voltage anymore, I get my scope gets mixed up, changing menus and wiggling all over the place. So like you see here, so this is because the pulse is now more outside in the environment by this symmetric cable. So, but I have a kind of 1500 or 1200 now pulse like peak, and I will see if I can measure the same when I move the probe again till up the tubing. Okay, same speaker wire hooked up, high voltage probe hooked up directly to the top of the coaxial tubing. 130 volts DC on the drain, and I have again this signal. I have to go back to 20 volts. Where is it? 20 volts per division. So we have a little peak-like signal, but it's a little bit better than with the coaxial cable, but it's nowhere near the pulse I put in. 133, and half of it goes down also. So I'm not sure where my pulse is going. Perhaps I should make a short at the bottom of the coaxial tubing, so make it a shorted, or perhaps a 50 ohm or 75 ohm resistor put at the bottom. I'm not sure. Have to think about it. Somewhere the pulse, which is definitely here at the diode, is not visible where it should be at the tubing, so nothing happens into the electrolyte. Okay, any comments are welcome. Thank you for watching.